Hey there, math students. So today our I can statement is, I can solve one-step equations in context. So a lot of you have probably already figured out what that means. That means word problems. Yay! All right, so let's go ahead and do our warm-up. For the warm-up, number 16, it says, and don't worry about do the following look familiar? Whatever, let's just get rid of that. Number 16 says, after paying $5 for a drink, Addie has $38. How much money did she have before buying the drink? Okay, so if she had some amount of money and then she paid $5 for the drink and then she had $38, how much money did she have at first? And how can I write that as an equation? That's what we're going to do. Write it as an equation. So let's go ahead and set up our variable. The question is asking us how much money. So the thing that we're trying to represent with the variable is going to be money. So let's go ahead and use an M. And let's say M equals money, just so that we don't forget what the variable stands for. Okay, so again, she had a certain amount of money, then she bought a drink for $5, and then at the end she had $38. So in the beginning, the amount of money she had is called M. We don't know what it is yet, so we're just going to write M. And then she pays $5. So does that mean she gains 5 or she loses 5? She loses 5. So you're going to do M minus 5 equals the amount of money she had at the end, and that would be that 38. So M minus 5 equals 38. And once you have this equation, you can solve by adding 5 to both sides, and you are going to get M equals 43. So you know that she started out with $43. Now, you may be the kind of person who reads this problem and you're just like, boom, 43, I know the answer. I don't have to write the equation. And that is awesome if you can do that. But you still need to practice writing these equations, because as you get into more and more complex math, and I mean this year and next year, I don't mean like college, I mean soon. As you get into more complex math, you're going to need to know the step-by-step process to do really complicated problems that you can't just do in your head super fast. So now is the time to figure out how to write those equations. Let's go on to number 17. Cameron won 112 bottles of soda at the school carnival. I'm going to underline 112. Okay, he then gave 4 to every student in his math class. So 4 to each student. He only has 8 bottles left. I'm going to underline 8. How many students are in his math class? Okay, so let's go ahead and set up a variable. This is kind of one of the more complicated ones. I said you'd get there soon, right? This is kind of hard to do in your head. Maybe you can do it in your head, but it's not going to be like a light bulb moment. Oh, I just know the answer. You have to think about it a little bit, right? So let's define our variable. It says how many students. So what are we asking about? We're asking about students. So our variable is going to be S. Now, could you use X or P or whatever? Absolutely. I'm just going to use S now because I choose to. So S is going to equal students. Okay, let's go ahead and read it one more time. He won 112 bottles of soda at the school carnival, and then he gave 4 to every student in his math class. At the end, he only has 8 bottles left. Okay, so what happens at the beginning? At the beginning, he has how many bottles? He has 112 at the beginning, because that's how many he won. So he starts out with 112, and now he's going to give some away. So if he's giving them away, should we add some or should we subtract? Yeah, let's subtract. Good. Okay, so now how many did he give away? Well, he gave 4 to every student in his math class. So how can we represent that? 4 to every student would be like 4 times the number of students. And we're representing the number of students with an S, so we're just going to write 4S. And now it's going to equal the amount he had left after he was done giving them away, which is 8. There it says 8 bottles left at the end. Okay, so now once you have this is a 2-step equation. Not a 1-step equation. I don't know why it's on this page. Don't ask me. But this is a 2-step equation. We would get rid of the 112 first. So minus 112 from both sides. And I'm going to continue writing over here. So that goes to 0, and you're left with negative 4s equals, let's see, 8 minus 112 is going to be negative 104. Okay, now we got to get rid of that negative 4, so divide both sides by negative 4, and you get s is equal to, let's see, 20. 26, right? Yeah. So S is equal to 26, positive 26, hopefully. Now, you're not going to ever get, like a question like this isn't going to have a negative number because you wouldn't have negative 26 students. So definitely check to make sure that your answers are making sense whenever you do a word problem. Okay, so 26 students is the answer here. This is a little bit more on the complicated end. Let's continue on and you'll see we're going to take it a little bit more back to basics. So example 3, this is just like what we had at the bottom of that other page yesterday. It's just kind of reprinted here. So let's read our words and see if we can figure out what they're talking about. In example 3a, it says, what is 4 less than 10? 4 less than 10. Okay, so you have 10, and then you're going to take 4 away because you want 4 less than 10. So you're going to start out with the 10, and then you're going to subtract 4. Now, it might be tempting to say 4 minus 10, just because you see the 4 first and then the 10. But that's not what the problem's asking. And order does matter with subtraction, so make sure you have that in the right order. When it says 4 less than 10, you need 10 minus 4. Okay, let's go over to B. What is 5 more than 7? Okay, so you're starting out with what? You're starting out with the 7, and then 5 more, so you're going to add or subtract? You're going to add. That would be 7 plus 5. And so that is going to equal 12. Over here, of course, it would equal 6. Now, could you say 5 plus 7 here? Well, yeah, in addition, it's commutative, so the order doesn't matter. But in terms of the wording, this is probably a better way to write it. Let's look inside the box here. Whenever the word than is used, that's like right here, right? Than and than. Whenever the word than is used to indicate addition or subtraction, we reverse the order of the numbers, or we flip them. Either way you want to write that is fine. So basically that last number goes first. See, last number goes first. So you're flipping the order of the numbers. Let's go on to example 4. Write the equation that represents each of the following. Do not solve. Okay, so that makes it easier on you. All you want to do is write the equation. Pay careful attention to the words and punctuation. Okay, the sum of 6 and a number is 1.4. Okay, what does sum mean? What operation does that indicate? Addition, subtraction, multiplication, or division? Sum, anytime you see that, that's going to be addition, okay? So now let's keep reading. So the sum of 6 and a number, mystery number, how are we going to represent that? Let's just make it x. You could put n or r or whatever you want, but we're going to make it x. So the sum of 6 and a number is 1.4. So how are we going to write this as an equation? It'll be 6 plus mystery number over here, that's your x, and then that is going to equal 1.4. It might be tempting to say, oh, sum, okay, so 6 plus 1.4, because those are the two numbers that just jump out at you. So make sure you're reading these carefully and thinking about what it's really saying before you write these equations. Now it says I don't have to solve this, so let's just keep going. 3/4 of a number is 20. Okay, so for the number, let's just do x again. Anytime it says of, I want you to think multiplication. Okay, so 3/4 of a number is 20. So we're going to do 3/4 times x equals what's over there, and that's the 20. Okay, so this is multiplication here. Sometimes you might see it written with parentheses like that. You might even see the x up there with the 3. That's a little less standard though, but it would still be correct. All right, let's go on to C. Twice a number is negative 20.8. So what does twice mean? It means you double it. It means you multiply it by 2, right? So twice a number, let's use a different variable. This time we'll use n, okay? So if you double the number, you're going to get negative 20.8. So it sounds like we need to multiply the number by 2. So 2n, and what is that going to equal? Negative 20.8. Okay? And let's go over to D. 18.96 is 6.4 less than a number. Okay, so we have that less than, right? There's the less than right there. So what are we going to say for the number? Let's do n again. So remember our little tip. Whenever you have the word than, you're going to reverse the order. And less than means reverse and then subtract. So we're going to start out with our in, and then for the less than, we're going to go minus. And how much are we subtracting? We're subtracting 6.4 because we're trying to figure out 6.4 less than a number. So the number minus 6.4. And what does that equal to? It equals that 18.96. Okay, so that's your equation. If you would rather write it as 18.96 equals n minus 6.4, that's totally valid. It can be either way around. Let's go on to number E. Number E, letter E, whatever that is. The product of a number and 1/4 is 14. Okay, so for this time for the number, let's do y. And let's think about these words. Product, what operation does that indicate? Addition, subtraction, multiplication, or division? That is going to be multiplication. Right. So you take a number and you multiply it by 1/4 and you're going to get 14. That's what the problem is saying. So let's do 1/4 times our number, which we're representing with y. 1/4 y equals 14. And there you go. Okay, so those are all the examples under example 4. Let's go to example 5. This is one where we actually write the equation and then solve. So that can be kind of nice too. It feels like you actually solve the problem, literally. You spent $5.25, which was 1/4 of your allowance. Okay, how much was your allowance? Okay, so what are they asking you first of all? They're asking you how much was your allowance. So this is what your variable should represent. So let's just call that A. A equals allowance. All right. So you spent $5.25. That's how much you spent. That was 1/4 of your allowance. So you want to take 1/4 of your allowance. Remember the of, what we talked about up here? That is always going to indicate multiplication. So let's do 1/4 of your allowance. Again, allowance is A. And what does that equal? That equals this $5.25. And again, if you want to do it the other way around, because the problem lists the $5.25 first, you could totally do that. $5.25 is 1/4 of your allowance. So either way, and now I should have written it over here so I had room to solve it, but I'll just recopy this. 1/4 A equals $5.25. So do you guys remember from yesterday how to get rid of that fraction in front of the variable? Yeah, you're going to multiply by the reciprocal. So we're going to multiply both sides by 4/1, which is the same thing as 4. So over here, it's a little bit more convenient for me to just say times 4. So that's what I'm going to do. But remember, I can say that because 4/1 and 4 are the exact same number. So these are going to cancel out and leave us with A equals, I'm going to go ahead and grab my handy calculator here, 525 times 4. And that equals 21. So your allowance, final answer would be $21. And that's your solution there. Okay, let's go ahead and read through all of these kind of like hint words for your word problems. It says, it's important to understand what words translate to different mathematical operations and concepts. Here are a few. So let's list our addition words. Addition, we've got sum, more than, don't forget to switch the order, total or increase. For subtraction, we have difference, less than, very important to switch the order there, and decreased. For multiplication, look for words like product, of, factor, or double, triple, twice, quadruple, things like that. For division, you would think quotient, out of, half, or third, things like that. And for equals, that would be is or yields. Okay? So like up here where you have is or is here, that is always going to be your equal sign. I don't think they used the word yields anywhere in here, but yields would be the same thing. Okay, so just a little bit more. This is not a complete list, and these words will not work in all cases. That's the sad truth. This list is a good place to start, but it's more important that you think about what is going on in the context of the situation. So that means read the problem and really think about what's going on and make sure what you're doing makes sense. So think about what's going on in the context of the situation to figure out how to set up an expression or equation to help you find the solution. If you don't know a word in a story problem, look it up. In short, sometimes you have to use your brain. You really do, because with word problems, you always need to go back through and just make sure that the answer makes sense. Before I let you go, let's look at 2 examples from your assignment. Okay, so in your assignment, I feel like it's just a little bit long, so I'm going to ask you to do 1 through 8. If you want to skip these 4 at the bottom, that is fine. And then on the next page, I'm going to go ahead and have you do all 6, but really, if you look at number 17, we kind of just solved that on the other page, so it's really just 5. But you can skip numbers 9 through 12 if you want to. So I'm going to show you right now the first problem from each page. So number 1, it says, okay, this is the great part. Read your instructions really carefully. It says, write an equation that represents each problem. Do not solve. So guys, you don't have to solve these. Yay! The important thing we want to see is that equation. So let's look at number 1. 6 times a number is 2.4. I'm going to represent that number with x. You can represent it with whatever letter you want. So 6 times the number. What operation is indicated by the word times? It's multiplication, right? Okay. And then that's kind of be your equal sign, right? So 6 times a number, so 6 multiplied by the number equals 2.4. Okay, I think we've got this. 6 times x equals 2.4. And then you're done. You can go on to the rest of the problems. Let's look at the first one from the second page. Now on the second page, you do get to solve the equations, so please do give me an answer there. Let's look at number 13. It says 5 more than a number is negative 2/7. Okay, so let's define our variable. The number, I'll go ahead and use x again. And when we have this more than construction, you're going to think addition, and you're also going to think to switch the order. So we start with a number, and then more than is going to be plus, and then 5. So 5 more than a number is, there's your equal sign, and then you just got your negative 2/7. And so what is the number? That means we need to go ahead and solve. So we got to get the x by itself. We're going to solve by getting rid of that 5 by subtracting it from both sides. Okay, that's going to cancel out to 0, and you're going to be left with, let's see, same sign, add and keep. So 5 plus 2/7 is just going to be 5 2/7, and we're going to keep that negative sign. Now, if you happen to do yours as an improper fraction, that's totally fine. You could do 5, let's see, 5 times 7 is 35. So that would be the same thing as 35/7. And so that 2 plus 35 would be 37/7 and still keep that negative sign. So I'll just write a little or there. However you like to do that is fine. And there's your answer. Thank you so much for watching. Let me know if you have any questions, and I will see you next time. Bye.